This is the 1-1B lesson, linear expressions and real world contexts. We're going to focus on some short word problems. That's what real world context refers to. And we're going to focus on expressions, which means that we are not going to have equal signs aside from simplifying. So an expression looks like this. Um, Essentially an equation without the equal signs. Linear expressions can be used to model many real world contexts. For example, if you buy 3 pieces of chicken that costs X dollars each, a slice of pie for $3, and a drink for $2, we can write an expression that represents the total amount spent as 3x plus 3 plus 2, which would simplify to 3x plus 5 because we are doing something we did in which is combine like terms. We represented these as unit tiles, and we can add those unit tiles together. And then that is fully simplified. So let's look at the first problem. It says a salesperson gets a base salary of $300 per week plus $20 for each item he sells. He sells X items in 1 week. The salesperson also spends $40 a week on travel expenses. Part A, identify the unknown quantity. Write an expression that represents the total amount of money that the salesperson had at the end of the week and simplify. In part B, if the salesperson sold 50 items, how much money did he earn at the end of the week? Well, this is one of the first lessons that we've done. And in you should have spent a good deal of time on doing let statements. But in fact, for this one, they essentially set up our let statement or picked our variable. This won't be the case in B honors, but in this lesson, it does do that. These are going to be pretty easy problems, but we're going to review kind of what is good math. What are some of the things you did in that you took a break from over the summer? In a let statement, that would be one of those things. You don't have to put the word let, but you do need to write out what X equals to, or if you're choosing a different variable, you can also do that. You can abbreviate a little bit, like number of items. I'm going to leave the let be where it was. All right, so there's a base salary. You might annotate this with a pencil, pen, or highlighter, $300 per week, $20 for each item sold, and spends $40 a week on travel expenses. And it does say at the end of the week, meaning 1 week. So what that means is base salary of $300 only occurs once because we're only looking at a 1 week time period. This person earns $20 for each item, which would be 20x, meaning that if this person sold 20 times 2 would be $40. And spends $40 a week, speaking of 40, would be minus 40. And then we're going to combine like terms, and that would be 20x plus 260. We want to have the x term in front. That is a requirement, and the constant at the end. So this is sort of our draft answer, and then here it is fully simplified. Part B, we're going to let x equal 50. So where did they get this number? They just randomly picked it. And then you might also ask yourself, which if you haven't asked yourself this, you do want to think about this. Which one should I plug it into? Well, actually either one, but the best one would be to plug it in the simplified one because it'll be more simple to use the simplified one. And then we're going to write a sentence. You don't have to use a therefore dot, but a therefore dot is a triangle, and it represents or is shorthand for therefore he earned $1,260. And you could check your work by plugging in 50 into the other expression. But aside from that, there is not usually a way to check expressions. You can check equations, but not expressions. And we're writing sentences, even if it doesn't specify it. Number 2, Tim took his friends to the movies. He started with $40 and bought 3 movie tickets that each cost X dollars. He also bought 1 tub of popcorn that cost $5.75. A, we're going to do the same thing. And then B, if 1 movie ticket costs $8, how much money did Tim have left? All right. So again, it's kind of silly. They already did our let statement, but we're still going to write it out. X equals the cost of 1 movie ticket. As silly as a let statement is, as these word problems become more complicated, if you don't write this out and you get an answer for X, let's say 5, without a good let statement, you won't know if they bought 5 tickets or if a ticket was $5. But a good let statement, we know then what this is and how to label our answer. Started with $40, reduced that by 3 tickets, so 3x, and then also bought a tub of popcorn, so spent $5.75. And then we're going to combine like terms, negative 3x, and we're going to combine these, which are our constants, which leaves us positive 34.25. I would not overuse a calculator, but to speed up some of this number crunching, you can use a calculator, but you should also be able to do 40 minus 5.75 without a calculator if you had to on a quiz or test. So by all means, have one out to speed through some of this. Make sure you understand the math though. And then we're going to take this and let x equal 8. And we have negative 3. Plug in x, either a times dot or parentheses, plus 34.25. I ran out of room, so I'm going to go up here. Do you see my error? I just caught it. It should be 2.5. Cool. Therefore, Tim has $10.25 left over. Another way to kind of just check your work is to make sure that it just makes sense common sense wise, in that if he started with $40 and he now has $10.25, that does make sense. We wouldn't want his amount of money to go up in a word problem like this. Last one on the page. Sarah bought 3 baby outfits and 1 bottle of baby lotion. The baby lotion costs X dollars per bottle, and each outfit costs $2 more than a bottle of baby lotion. A, identify the unknown quantities, write an expression, and B, how much money was spent if 1 bottle of baby lotion cost $3.50. If you're up to the challenge, I would suggest pausing the video and trying this one on your own, and then watching it and comparing my answer to yours. And then if you've now tried it, here we go. So X is the cost of a bottle of baby lotion. And Sarah bought 3 baby outfits and 1 bottle of baby lotion. The baby lotion costs X dollars per bottle, and each outfit costs 2 more. So that would mean then X plus 2 is the cost of a baby outfit. So we actually have 2 let statements. All right, we're ready to go. So 3 outfits, 3, each of them is X plus 3, X plus 2. So 3 times the quantity, X plus 2, plus X. And we're going to apply the distributive property. So 3 times X is 3X, and 3 times 2 is 6, plus X. And then we're going to combine like terms. You don't need to mark the terms, but if you need a refresher, 3X plus another X is 4X plus 6. There's our simplified expression. And now we're going to plug in $3.50 or 3.5. So 4 times 3.5 plus 6. 4 times 3.5 is 14 plus 6 is 20. We might say something that $20 was spent or $20 was spent on the baby products, period. And that was the end of the first page.